and welcome to a new TaxonWorks tutorial, a brief introduction to creating interface using VueJS framework. In the first part, we will see the basic concept of VueJS, how to generate an application and how to create a task in TaxonWorks. We will see the Vue basic concepts, what is a single file component and what you can do with them. Then, we are going to see the main difference between Option API and Composition API, and how to write a component in both cases. We will see some of the most important directives in VueJS, how to pass information from a parent component to a child, and how we can create a communication between them. Then, we will learn how to use watchers and how to execute code in the life cycle of the component. After that, we are going to see how to prepare your environment and what tools you can use for it. You will learn how to use Vue developer tools to debug an application. On the second part of this tutorial, we are going to focus on creating a new application from scratch and using TaxonWorks API. This tutorial is a brief introduction to VueJS, and we will see only the essentials that will help you to understand better when we start to code a new application. It is not intended to be a full tutorial. For more in-depth knowledge, I recommend you to read the official documentation and create a new application to practice. Say that, grab a cup of coffee, and let's start. The first step we should do is create our first Vue application. There are multiple ways to do this, but I will recommend you to use Vite or Vue command line interface. Vite is a build tool that comes with a development server and it handles your code for production user role app tool. It is similar to Vue command line interface but lighter, faster, and can be used with other libraries like React or Svelte. Vue command line interface is a full system for rapid Vue development. It has more extensive features than Vite for more complex scenarios. Unlike Vite, this tool uses Webpack to bundle your code. But if you don't want to create a standalone application and you want to create a new task inside TaxonWorks, there is a raise task for it. Running this command line will create a ready-to-run application. You can read more about this in TaxonWorks documentation. Now that we saw how to create a Vue application, let's see how is the structure of a project generated with Vite. The node module folder contains the node dependencies necessary for our project. The source folders contain everything related to our application. The index HTML file is used by the development server to render our application. Let's see it inside. There is a script tag that points to the main.js file. Inside this, there is a function called createApplication, which is important for Vue package, and a component called app, which is the root component of the application. Then, createApp is called, and app component is passed as parameter to initialize the application. Then, it is mounted on the element with identifier app. Let's take a look how it looks the root component. Inside it, there are parts of JavaScript, CSS, and HTML code. This is a single file component. A single file component is structured in three parts. The first is the template. Here's where we put everything we want to render on the page, our HTML code or children components, for example. The second part is a script section. Here's what we put the logic for this component, our JavaScript code. And the last section is a style. Here's what we put our CSS code. Let's see how we add a component inside another component. First, we have the initial file. As we saw before, in this file we import the function createApp from Vue package, which is used to create an application. Then we import app file that will be the root component. Now, imagine that we want to add two children to the root component. Let's call them main component and header component. Inside the template section, we add the components we want to render. Then, we import this component inside our script section. Now, our application will render the root component, main component, and header component. Let's see a graphic example of how this works. On the left side, we represent a web page. and on the right side we put a graphical representation of a Vue application. We start with an empty page. This is the app view file. Following the example we saw before, let's imagine we want to add a header and a main section. Let's create two components for it and import them in the application component. As you can see, both components are children of the application component. Then, we want to add two more sections inside main, let's say information and image gallery. So, we create those components and we will put them inside main component. Probably at this point, you realize this is a tree structure. One of the most important things is making the components reusable to simplify and avoid code duplication. For example, gallery component have inside 3 image components which are the same component but each one have a different information. We will see this later. Let's see another example of how we can split a page into components. What you see here, it could be a simple taxon page. We have a lot of sections that can be components, so let's start from the top. We can create a crumbed component for the taxon hierarchy. For the search input, we can create an autocomplete that allows us to find a taxon. For the taxon name, we can create a component called taxon component, and inside it, this component will render the rank and the name. For download a JSON bottoms, we can create a component called export and add 2 components inside of it for each task. For the tabs, we can create a menu component. For the image, a component called gallery, and inside of it we can split in more components, for example, image component for each image. Then we have another one for the map, common names, external resources, type specimen, synonyms, etc. At this point, you should have an idea of how this works. Now we know how a component works and there are different sections, let's see an example of it. In this template, there is an HTML code, a view component called menu component, and a button with a click event listener. Let's take a look at the script section. Here, we import a menu component and we export an object with different properties and functions. The components object is where we place the components that we want to use in the template. Then, we have a data function that returns a reactive object. Here's what we put our data. Every change we made here will be reflected in the template. Then, we have another object called method. Here's what we put the functions that we use in our component. Let's take a moment to look at it. In the template section, when the user clicks on the bottom, the click event calls the increment method to increment the value of count. Then, the template is updated because count is a reactive property. So, the first time the user will read, you click 0 times. Then, when the user presses the button, this will change to you click 1 times. Pretty simple, right? This way to write a component is called Option API. You can use it on VueJS version 2 and 3. Let's take a look at the structure. Look how easily and well organized are our code on each section. It looks great when we are creating a small component like this one. The problem comes when we have a large component. It starts to be quite difficult to read. To solve these and other problems related with code reuse, the VueJS team introduced a new way to write component, and it's called Composition API. The new API is available in VueJS version 3. It allows features to be grouped together logically rather than having to organize your simplified component by sections. Now, let's see the same component but written using Composition API. As you can see, the template is exactly the same, but the script section is different. There are 2 ways to write a component using Composition API, but in this tutorial we are going to focus on the one called sugar syntax. For this, we have to add setup keyword in the script section tag. The first thing that probably you are looking now is that we have to write let's go for the same behavior. Let's see what's different. When we import a component, we don't have to put it inside a components object. We can use it directly in the template. We don't need a data section. We just create a constant and we use the function ref, which will create a reactive and mutable object with the provide value. To use ref, we have to import it from view package, and this is because when we use Composition API, we only import what we need to use. Now, let's take a look more closely about the reactive data in both APIs. When we work with Option API, we put everything that we want to make reactive inside data function. If our data is not there, it won't be updated on the template when it changes. For Composition API, we use ref. that will return a reactive object. Let's take a look about how we assign a new value. In Option API, to access object, functions, and properties, we have to use this. For Composition API, we have to assign the new value to value property. There is another way to create reactive objects. For this purpose, we use reactive function. This one only accepts objects and not primitive values like ref function. In this case, we only have to set the new value directly to the object property. Now we know how to make our data reactive, we are going to see how to render it on the interfaces. There are 3 ways to do it. The most common way to do it is with mustache syntax. The mustache will be replaced with the value of object tag property from the corresponding component instant. It will be also updated whenever the object property changes. Another way is using btext directive. This one updates the element text content. The double mustache and btext directive interprets the data as plain text, no HTML. In order to output real HTML, you will need to use bhtml directive. Now we know how to render data in the template section, but what about conditional rendering? Sometimes we have to render different elements on the interface depending on our data. For this, we have 4 different directives. The 4th directive, bShow, it always renders the element even if the condition is false. But the difference is when the condition is false, the element will be hidden using CSS property. This is good when you want to optimize your application, because it won't destroy the component inside this condition. Let's talk about a slot, another feature for templates. Slots are reserved a space to display content passed down from a component to another. There are 2 types of slot in VueJS, namely named slot and unnamed, default slot. In this example, we create a simple component with an unnamed slot. In the parent component, everything we put inside of it will be rendered in the slot tag. Now, let's take a look at the second example. In this car component, we have 2 slot sections, one for the title and another one for the body. For these cases, the slot element has a special attribute, name, which can be used to assign a unique ID to identify a slot so you can determine where content shall be rendered. A slot outlet we have name implicitly has the name default. Now, everything inside the template element will be passed to the corresponding slots. Now we know how to work with the slots and conditional rendering directives, it's time to see a real use case for them. In this example, we replicate the model and button components that are used in TaxonWorks. Let's take a look how it works. When the user presses the button, it will trigger the click event, which changes the show model state to true. Now the model renders because if condition is true. In the footer slot, there is another button that will change a slot model state to false. So, when the user clicks on it, the condition will be false again, and the model will be destroyed and removed from DOM. In this example, we have a taxon list with 3 different names. To render a list of elements, we can use before directive. The before directive requires a special syntax on the form of item in items, where items is the source data array and item is an alias for the array element begin iterate on. The key special attribute is used as a hint for Vue virtual DOM algorithm to keep track of the node identity. That way, Vue knows when it can reuse and patch existing node and when it needs to reorder or recreate them. Let's talk about computed properties. In this example, we have a list of taxon names and an input to apply a filter to that list. When the user writes part of the name, the list should return only the names that include what the user types. For this, and in-template expressions are very convenient, but they are meant for simple operations. Putting too much logic in your templates can make them bloated and hard to maintain. Let's create a computer property for this. We move the code there and we replace the code in the before line. Now we have a cleaner template. Keep in mind, there are computer property we only re-evaluate when some of its reactive dependencies have changed. This means as long as taxon list or input name have not changed, filter list will return the previously computed result without having to run the function again. Let's take a look at the same component we used before. What if we want to have a multiple list of taxon names? Let's say we have a genus and a species list, and we want to use this component to filter each list. Well, we don't have to copy and paste this code into a new file to create the same component but with a different list. There is a more efficient way to do it that will allow us to reuse this component, and that way is using props. Props are custom attributes you can register on a component to pass data from the parent to the child component. Let's define a list attribute using the find_props function. Note that it is not necessary to import this function from Vue package when you are using Sugar syntax. When we define props, we can define the type of value that the attribute will accept, and we can indicate if it is required or not. There are more options we can set it there, for example, validations or default value, but for this example we don't need them. Now we can reuse the same component multiple times to display different lists without need to create a new component for each one. We already saw how to pass data from parent to child using props. Now we are going to see how to pass data from the child to parent. In the following example, we have a list of taxon names. Each row has a button to delete the name. When the user presses one button, the name should be removed from the list. The taxon list component receives the list from the parent. Props shall not be modified by assigning a new value to them. In order to modify the list, we must do it from the parent component. For this task, we create a custom event that will allow us to communicate with the parent. To define a custom event, we will use the find_emits function. Like the find_props, we don't need to import it from the Vue package. In the parent component, we import the taxon list component and we will pass the list of names to it. The @ symbol is the short way to use directive beyond to listen to the events emitting from the component. Then, when the user clicks on the button, the click event is triggered. It calls the emit function, which will emit onDelete event, sending the position of the item in the array. The parent component receives this event and calls the remove from list function, which will remove the name from the list. Each component instance goes through a series of initialization steps when it's created. For example, it needs to set up data observation, compile the template, mount the instance to the DOM, and update the DOM when the data changes. Along the way, it also runs functions called lifecycle hooks, giving the user the opportunity to add their own code at a specific stage. Some of those lifecycle hooks don't exist on Composition API. Let's see some examples of this. We are going to create a component that requires a list of taxa by name. We will take the name parameter from the URL of this application to get the name. First, we write the template for the list. Next, we are going to write the component using Option API. As we saw before, when using Option API, everything must be contained within sections. We must use the create hook to make the request when the component is created. Now, let's see the same example, but now we are going to write it using Composition API. As you can see, we don't have to use the created hook because our script runs around the before created and created lifecycle hooks. You don't need to explicitly define them. In other words, any code that will be written inside those hooks should be written directly in the script section. Let's take a look at another example using Composition API. Here, we will use Radial Menu Library, which needs to receive two parameters. The first is the DOM element and the second is the options. This is a good example of how to directly interact with the DOM elements within Virtual DOM. The first thing we must do is assign the ref property to our element. We put radial element as value. Inside the script, we create a constant with the same name and we use the ref function with a new value. When our component is mounted, the value of radial element will be the DOM element. Since we must wait for the DOM element to be created, we have to use the unmounted hook. Let's imagine we have a component to display the information of a taxon. This component accepts the taxon ID as attribute. The component takes the ID and makes a request to get the taxon data. The question is, how code will make a request every time the taxon ID value changes? If we use the created or unmounted hook, it will only work the first time that the component is initialized. For this, we will use watch function. Let's take a look closer at how it works. Let's hide this block of code for a moment to see how a watch function looks like. A watch function has three parameters. The first is the data source that will be observed for change. It can be one or an array with many sources. The second parameter is the callback function, which accepts two parameters. The first is the new value, and the second, the old value of the data source. The first parameter is optional. Here we can set how the watcher shall work. The immediate option will trigger the watcher when the component is created, making it work like a created hook. The deep option will be used to search the change inside object properties and array elements. Let's take a look at the code block again. We pass the prop taxon ID. Every time its value changes, it takes the new ID and makes the request to get the data of the taxon. By default, we want it to always work when the component is initialized. Now that we know the Vue basics, it's time to start writing our first application. But before that, you need to prepare your development environment. You will need a code editor. A good option is Visual Studio Code. It is a lightweight but powerful source code editor which runs on your desktop and is available for Windows, macOS, and Linux. It comes with built-in support for JavaScript, TypeScript, and Node.js, and has a rich ecosystem of extensions for other languages. There are 6 extensions for this that will make your experience more enjoyable. ESLint is a tool for identifying and reporting on patterns found in JavaScript code. It will help you to write better code following rules. JavaScript code spinets will help you to write code faster. Volar provides syntax highlighting for all your VueJS source code files. VueJS Development Tools is a browser extension for debugging VueJS application that will speed up your development and bug hunting. Version 6 supports Vue Free. At the time of recording this video, it is in beta and available for Chrome and Firefox. When we open the browser inspector, we will have a tab with the name Vue. Clicking on it, we will see the Vue DevTools interface. In the top of the bar, we have an application selector that will allow us to select which application we want to debug in case there is more than one initialized on the page. Inside the Inspector tab, we have a tree view of the application. Clicking on a component, we can see the states. The Timeline tabs provides a view to analyze events and performance. This is useful to analyze if the events are fired when they should. For example, if they are doing it more than once, and if we have performance issues. This has been the first part of the introduction to TaxonWorks interfaces. In the second part, we will create an application where we apply the basic concept of Vue that we have seen in the first part.